In a new extended essay titled, "From Words to Worlds, Spatial Intelligence is AI's Next Frontier," Fei-Fei Li describes why the next major breakthrough in artificial intelligence, AI, will emerge not from improved language models, but from systems that genuinely understand and generate 3D, physics-consistent worlds. The limitations of language-centric AI. Li begins by acknowledging the tremendous progress that large language models, LLMs, and multimodal systems have made. These systems excel at abstraction, reading and writing text, even generating images or simple videos, and manipulating tokens in high-dimensional spaces. However, she argues these systems remain fundamentally detached from space, motion, and real-world physical interaction. They can process and generate language, but cannot reliably estimate distances, understand how objects will move, or reason about how actions change environments. For instance, Li points out that many generative AI systems still can't robustly answer, "How far is the cup from the edge of the table?" or "What happens if this ball rolls down the ramp?" In her words, many of today's systems are wordsmiths in the dark, fluent with words, but lacking embodiment in the world. What is spatial intelligence? Li defines spatial intelligence as the ability of a system to perceive, reason about, act in, and even generate three-dimensional environments in a physics-consistent manner. This includes understanding geometry, depth, motion, object interactions, causal dynamics, and time-evolving spatial relations. Humans and animals rely on spatial intelligence from early on, navigating environments, manipulating objects, predicting what happens when you push something, catching moving objects, etc. Li states that this loop of perception, reasoning, action, is a cognitive core of intelligence. The role of world models. To operationalize spatial intelligence in AI, Li argues we must build world models, AI systems that can construct internal simulations of environments, reason about how they evolve, and act within them or generate them. These world models must have three essential capabilities, as Li outlines. Generative spatial. They can create virtual spaces that are consistent in geometry and physics, e.g., objects obeying gravity, light, material physics. Multimodal, interactive. They accept input from multiple modalities, images, video, depth, action trajectories, and can respond to actions or perturbations in the world. Predictive/dynamic. They can forecast how the spatial world evolves over time, given actions or external forces, e.g., a ball rolling, a door opening. Li argues that current models, including state-of-the-art multimodal LLMs, do not sufficiently incorporate these capabilities. They may be excellent at static perception, identifying objects, or language generation, but struggle with reasoning about what happens next in space and time. Why it matters. Applications. Transformative potential. Li emphasizes that unlocking spatial intelligence will open up new frontiers across robotics, science, design, healthcare, and creative industries. Some concrete possibilities she mentions or are reported. Robotics and embodied agents. Robots that don't just follow pre-scripted instructions, but truly understand their environment, plan motions, adapt, and act in the real world, rather than just in simulations. Simulation for science and engineering. With robust world models, AI could simulate materials, molecular interactions, climate systems, or novel physical systems, by reasoning in 3D space, rather than only on symbolic or statistical abstractions. For example, the ability to predict interactions of objects in space could extend to physics, chemistry, or biology. Design, creativity, and virtual worlds. Generative systems that produce realistic 3D worlds are useful in gaming, film production, AR/VR, architecture, and other content creation domains. Li's startup is already working in this direction. Li argues that this shift from language-centric models to world-centric models is not incremental but foundational. It changes how AI interfaces with the real world and how intelligence is defined in machine form. The challenge. Why it's hard. Li does not present this transition as easy. She outlines technical, data, and modeling challenges. Data scarcity. Unlike text, where vast corpora exist, High-quality data about physical interactions, 3D scenes, depth, motion, and object dynamics is much harder to collect and annotate. Modeling complexity. Simulating the real world means modeling geometry, materials, light, physical forces, dynamics, collisions, continuity, much more complex than next-word prediction in a text model. Bridging modalities and actions. World models must integrate perception, action, and prediction in a loop. See the embodied intelligence notion. Many current systems excel at perception or generation, but not embodied interaction. Evaluation and benchmarks. Traditional benchmarks for LLMs don't capture spatial reasoning, prediction in 3D or dynamics. New benchmarks are needed. Despite the difficulty, Li asserts that momentum is building. Research labs and companies are starting to invest in large world models and spatial reasoning systems, from language models to spatially intelligent systems. To summarize her argument, language-based AI, LLMs, even multimodal, has unlocked major advances in abstraction, text, and perception. But true intelligence, as exhibited by humans and many animals, is embodied. It understands space and manipulation, not just words. Therefore, the next breakthrough in AI will come when systems move from words to worlds, i.e., from token-based reasoning to 3D spatial reasoning, simulation, generation, and interaction. Building this requires world models with generation, multimodal perception, interaction, and prediction. When that is achieved, unlocked possibilities will include more capable robots, scientific simulation, richer creative tools, and deeper integration of AI with the physical world. Who and what behind this vision? Fei-Fei Li is widely recognized for her pioneering work in computer vision and AI, notable for co-creating the ImageNet dataset, which enabled many of the deep learning advances in vision. She is co-founder and CEO of the startup World Labs, founded 2024, which focuses specifically on building spatially aware AI systems and world models. In her essay, she outlines her long-term orientation toward visual and spatial intelligence, which has been her guiding North Star, and why now is the moment to pursue it in earnest. Why this matters to the AI landscape. Li's articulation of spatial intelligence as the next frontier is significant for several reasons. It signals a paradigm shift from text/data-based intelligence toward embodied, spatial, interactive intelligence. It helps explain why many impressive LLMs, nonetheless, still struggle with tasks that humans find trivial: estimating size, navigating a room, cause and amp, effect in 3D. It gives a roadmap for research, funding, and startup directions, namely world models, simulation, 3D generation, robotics, multimodal embodied systems. It raises fundamental questions about how we evaluate and benchmark AI. If reasoning about space and time is central, then new benchmarks and data types will become important. It implies that many applications, robotics, simulation, material science, virtual worlds, may accelerate when spatial intelligence matures, with significant industrial, economic, and societal impacts. Conclusion. In her essay, From Words to Worlds, Fei-Fei Li makes a compelling, evidence-based argument that the next breakthrough in AI will not come from larger LLMs or more tokens, but from systems that understand and generate 3D, physics-consistent, interactive worlds. She positions spatial intelligence, the linkage of perception, reasoning, and action in space and time, as the missing cognitive core in current AI systems. To build it, we must develop world models capable of generation, multimodal input interaction, and prediction. The payoff could be profound. AI systems that truly perceive and act in the world, enabling advances in robotics, science, healthcare, design, and creativity. While the path is challenging, Li shows that momentum is here, and that this next frontier is not just possible, but essential for the future of AI. If you found this video helpful, don't forget to like, subscribe, and hit the bell so you don't miss the next one.